Lesson. I'm Terry VanNoy, and we've been talking about working with determinants. Determinants are from a matrix grid of numbers, and we're going to be talking about Cramer's rule for 3x3 systems. So 3 equations, 3 unknowns, trying to solve a system using what's called Cramer's rule. Now, you should be taking some notes. If this is new for you, you want to maybe go back to a previous video where I talked about finding the determinant of a 3x3. Now we're going to use Cramer's rule to solve the system. So here's what it looks like. So here's a 3x3 system, and you notice how I've lined up the x's and the y's and the z's. That's pretty important to do because you want to make sure that you aren't actually missing something. Now this is an example of missing a z term in that second equation. And so when you write down the coefficient matrix, which is just the x, y, and z coefficients, in a matrix 3x3, don't forget to fill in that empty spot with a 0. All right, because we're missing a z coefficient right there. And then we take the constant numbers that are usually written over on the right side as a 1x3 matrix. And so we have what's called a coefficient matrix and a constant matrix. Now Cramer's rule says that we're going to take a combination of these two matrices, and we have to find the determinant of the x's, determinant of the y's, determinant of the z's, and the overall determinant of the coefficients. So let's start with the coefficient determinant. So in this 3x3, to take the determinant there, I'm going to focus on this first column here. I'm going to copy the 4 down, and the -5, and the +5. But remember, we're subtracting the middle term here, so it actually becomes a +5. Okay, very critical that we remember that sign change. In the first group, if we're using this +4, which is right here, that of course means that I'm going to use the remaining numbers here, not in the same row or column, and write it down as a determinant. Now in the middle group, I'm using the -5, so I ignore that column and that row and make a determinant out of 2x2 grid out of the remaining numbers here. Last group, I'm using the +5 here, and I ignore that column and that row, which gives me this 2x2 determinant to find, and I'm going to write it in right now. Now for the rest of this process, I'm going to assume you remember how to take a 2x2 determinant. So it's going to be 4 times 2, 5 times 2, 5 times 2. Add those together, and just to speed this up a little bit, there we go. The determinant of the coefficients is 28. That's going to be part of how I find x, y, and z. So I have to find the determinant of the x's. It's usually labeled d sub x. Now what that means is that I copy down the coefficients here, but the constant coefficients here are going to be replacing the x coefficients. All right? In other words, everything is going to be the same, except if I'm going to be doing determinant of the x's get replaced by the constant numbers. That's kind of the common pattern here. So this is what it looks like when I write it all out. So the -12 is going to be multiplied by the matrix of the remaining 2x2, which will be these 4 numbers here. The -26, remember the sign change there, is going to be incorporating the top row here and the top row here. And the -18 is going to take these 4 numbers here. All right, so we've got 12 times that determinant minus 26 times that determinant minus 18 times that determinant. And to speed it up, here's what we get. The determinant of the x's works out to be -112. How's that for a process? Now we're going to do the same for the y's and the z's, and here's what that looks like. The determinant of the y's is going to be the x coefficients and the z coefficients, but the y coefficients are replaced by these constant numbers. Okay? So we're going to have this +4. Remember to focus on that first column there. Take the +4 and multiply it by the determinant of the remaining 2x2, which is these right here. And then the -5 becomes a +5. Remember, the middle group always changes its sign. And it's going to be this row here and this row here put together in a 2x2. And then we have the final 5 here multiplied by the determinant of these 4 numbers here. So all told, when we're done, we get the distributed or the determinant of y is negative 84. Now if you're having trouble getting the same answers as me right here, remember these are a determinant of a 2 by 2, and I have a video for that in this series earlier. So it's a matter of just making really careful work of all those negative signs and being accurate with that. So distributive y or determinant of y is negative 84. So determinant of the z's is going to be the x coefficients, the y coefficients, and the z coefficients are replaced by those constants. All right, hopefully you see the pattern there. Let's continue. Take a look how I've structured this. It's the 4 times that determinant. The 5, of course, changes its sign now. It's the middle group, and that's that determinant. And then it's this final 5 multiplied by this determinant. So make sure you're using the correct numbers there. So finally, we have our determinant of the z group, and that is positive 28. Wow, you can see how tedious that is and chances to make a lot of mistakes, but it's something you just have to kind of work on with some self-discipline. And then you've got the determinant of the coefficients. You have the d of x's, d of y's, and d of z's. Cramer's rule now is going to put it all together for us to solve for x, y, and z. So here's the answers we have so far. The determinant from the coefficients is 28. The determinant of the x group is negative 112. Determinant of the y group is negative 84. Determinant of the z group we just found is 28. So Cramer's rule is simply this. To find the x solution, you take the determinant of the x's and divide it by the overall determinant. The y is d of y over d. And the z value, of course, dz over the overall determinant d. So what is dx over d? That's negative 112 over 28, which is, happily, dividing out to a nice number of negative 4. All right. dy over d is negative 84 over 28, which is negative 3. And dz over d is 28 over 28, as you can see, and that would be positive 1. So after all of that work, finally, Cramer's rule is one method to solve a system like this. Now, it does take a lot of time and writing and effort, and you could use other solutions or techniques such as elimination in a 3x3, which is very complicated, substitution, maybe even graphing, but it'd be a 3D graph, so it'd be very complicated. So sometimes Cramer's rule does save a little bit of time. Now, in a x, y, and z system, you can also see answers written in a triple pair here. So that's going to be negative 4, negative 3, positive 1. Sometimes the solution is written that way. All right, thanks for hanging in there with me and watching this video. Take care.